if we look at the osmolality when we're doing cryopreservation, we are much higher than we would be in a regular media because we're using that to pull water. So we're using osmotic gradients, ES, the VS, to pull water and to replace water. So these are all important things to be aware of. Let's start with equilibration solution. What are we doing? Equilibration, the purpose of this is to take the intracellular water and move it out. We do that through dehydration. When we expose the cells, and I like oocytes, and I do a lot of work with oocytes, but it gives you a great visual representation of what's going on. So when we expose a cell to ES, we see it shrink as the water removes. But we also see them re-expand as the permeating cryoprotectants re-enter the cell. And this is an important process. If we just dehydrate cells, we can't just freeze dry everything and throw it in the freezer because the proteins will start to fold on themselves, the organelles will be broken. So we have to do this. An equilibration step is really important. The equilibration step uses penetrating cryoprotectants, ethylene glycol and DMSO in our formulations, at a half strength solution. The next step is our VS exposure. Now this is our most toxic or most potent exposure, and this is where time becomes much more important. ES exposure, we see everything from 6 to 12 to 15 minutes because we're wanting that action to occur. So you want to watch the cells and how they react. VS has a different purpose. VS is the first exposure to a sugar. With kitazoto, it's trehalose, but you'll see a very marked shrinkage because of that. So during equilibration, shrink, re-expand. Now VS, again, another shrink. We're pulling out that last bit of water. Now, one of the things I talk to people, which is really important, is when you go from ES to VS, we have two different drops. Why is that? It's really important that you remove any residual ES through those VS exposures. If you have any ES around the cells when you put it on the device and you plunge it, ES can form ice. That can give you micronucleations. That can give you little problems that can actually destroy the cells. So just putting the cells in VS and setting a timer and walking away really isn't enough. It's a very active, very deliberate activity to dilute, remove all of that ES. Really important. So it's an important thing that I find people taking for granted a little bit. The protocol says 1 minute. In most donor eggs, 1 minute's like magic. But sometimes it might need a little bit more time. Don't be afraid to give it another 10 or 15 seconds. Because every cell's different, especially, I talk about this in a lot of my fertility preservation patients. If you have an older lady's eggs, they maybe don't react as much as we'd expect. So don't be afraid to give them maybe a little bit more time and watch what's happening. I think it's important to not be a slave to your timer, but be engaged in the process. So during the VS step, the TS step, we want to see that shrink or the squeeze. So really important. This is an example of oocytes that on warming were flat. So it looked like they were stepped on, and they don't recover at all. This is an example of excessive VS exposure. So what can be excess VS exposure? Well, you were in there for more than a minute. That can be a problem. But it's also really due to loading technique. This is one of those examples where trying to be perfect can work against you. So when you're loading your device, you got to think about, okay, I'm dealing with 1 microliter here. And if I'm like, okay, I'm going to be perfect, while you're doing that, it's evaporating like crazy and it's concentrating. You can get an overexposure event. Your pipetting technique, your loading technique, you've got to be proficient.